Hi everyone, welcome back. So Leetcode daily question today is delete nodes from linked list present in array. So we are given an array of integers, nums, and the head of a linked list. We have to return the head of modified linked list after removing all the nodes from the linked list that have a value that exists in nums. So all the values that are in nums array we have to delete from the linked list. This is the question. There are several ways of deleting a number from a linked list. We shall see them today. So the first approach that we can do is just create a new linked list, the modified linked list. One thing we have to do is for every value in the linked list, we have to search if it exists in a nums array or not. And whenever searching comes and we have to optimize it, in O1 time we use hash set or tree set for search time optimization. So we have used a tree set, we can also use a hash set. It is fine, both work well. So we have added all the values of the nums array to our set. Now we want to create a modified linked list. So we have created a new list node dummy. This will be our new head pointer, and we have kept a temporary variable pointing towards the dummy. This shall act as a tail variable. So every new node we will add through temp. Now what we have to do, we have to traverse our original linked list. So while head is not equal to null, we will check if set contains head.val. If it does not contain, then we have to add it to our new linked list. So if it does not contain, we will add a new list node temp.next is equal to new list node add.val. So new node is created and stored to temp.next. Now temp will move forward. Temp is equal to temp.next. So if it contains, it will do nothing, and head will just move to the rest of the next node. At last, we have to return the head of the modified linked list. So this was the head node, this was the tail pointer, but the original data is from the next node, so we will return dummy.next. So this was the simple solution using a new linked list. We shall now see a recursive approach for the same question. So this is the recursive solution. In recursive solution, what we shall do is first we shall traverse the linked list, reach the end, and while coming from the end, we shall check if the data exists in our hash set, then we shall return the next. Otherwise, we shall return the address of the same node. So this will help us to delete the node, because if we return the address of next node, then this node is presently deleted for the previous node, right? Because we move from here to here to here to here to here, and we shall be, while returning, we shall be storing the address returned to the node. So if 5 is deleted, it will return null, and null will be stored in 4.next, right? Node 4.next. And we check again, it is also present, so it will return its next. That will be null. So null is returned. So 3.next will be is equal to null. Now we will check if we had this was the explanation if we had to delete 4 and 5, but in this question we are deleting 1, 2 and 3. So this is how it works. While returning, while coming back, we shall return the address of the next node if we have to delete the node, or otherwise we shall return the current node's address, which will be stored in the previous node.next. So we have created a set, we have passed our set to the recursive function. Our recursive function will have our head and the set. We will check if we have reached the end, we will just return null. This is our base case. Now we shall move forward. We shall first go towards the end of the linked list and keep storing the returned address in next. Now whatever we get from our recursive function, that shall be our next for the current node. So head.next is equal to next that we have received from the recursive function. Now what we will return from the recursive function, if our hash set contains If our set contains the head.well, that means we have to delete the current node, so we will return its next. So we are returning next. Otherwise, we just have to return the present node address. So this is the recursive solution to delete a node from a linked list coming from last to first. These two are the simple solution. We shall see another approach, that is deleting the nodes from the current list itself and moving from forward to the last, means iterating through the list. This is the last approach we shall discuss today. So while moving forward, if we have to delete certain nodes from a list, first what we have to do is, same, we have created a set, added all our values to the set. Now if our head itself, if the starting node itself has to be deleted, we have to move the head pointer ahead, right? So first we have to remove the nodes from the beginning that are to be deleted. So that we will do first. So while head is not equal to null and value to remove dot contains head dot well, means the starting value is to be removed. We will just keep moving the head pointer to the next, because just changing the head works fine for removing the nodes from the beginning. Now if our head is null, nothing else we have to do. We just have to return the null because our list is completely removed. Otherwise, we have to traverse the remaining nodes and check if something is to be deleted. Means we are deleting from the middle or somewhere, not the starting. We have a head, right? So we have created a new variable current which points towards the head. Now we will work till current.next is not equal to null. Now we will check if values to remove contains current.next.value. We will check if the next node is contained in the set, then we have to remove the next node. So current.next will become current.next.next. So the next node is removed if it is contained in the set. Otherwise, we just have to move. We just have to move to the next node. So we move ahead. Current is equal to current.next. And at last we have to return the head. So this was the simple solution, moving from forward to the end. So we saw three approaches: making a new list, coming back in recursion, or moving ahead using iteration. So I hope you guys would have got the solution. Thanks for watching the video. Have fun. Bye.